Okay, so in this recording, I'm going to go through the final lab report guidelines for our PCC lab testing report. And essentially, what I'm going to be doing is I'm going to be going through three documents. I have the assignment itself, I have the grading sheet, and then I have the report template. So I'm going to go through these one at a time and just sort of indicate what I think is important, what I don't think is important, et cetera. And so let's just go ahead and jump right in. So the first document that I want to go through is the actual assignment. And so this document is basically what you need to do. This is what you need to submit. Okay. The second document is how I'm going to grade it. And the third document is how you should write it. But this is what you're doing. Okay. So let's just go through it. So your group's going to produce a lab report that summarizes your activities regarding the PCC mix design that were produced and tested throughout the semester. So, I mean, there is quite a bit that goes in that. I mean, this goes from really honestly the day that you watched Patrick and I do the demo of the mix to the fresh casting day to the 7-14 day testing and the 28-day testing that we're about to do this afternoon. Okay, so there's a lot here. Okay, so what goes into this? So there's going to be a cover page and a table of contents. The introduction. So when it comes to the introduction, let me say this. So the introduction, I have here a 1 to 2 page summary of tests performed. I kind of think that might be a section you want to write last. Because the introduction, so I use the term introduction. Another name for it might be an executive summary. But the idea that you should be keeping in the back of your head about the introduction section is if somebody didn't read your report and all they read was the introduction or the executive summary, have you stated enough in there to provide a high level overview of all of the content in your lab report? So that's why I think it's a good idea to write it last. And it'll be like 1 to 2 pages. I mean, there'll be a lot there. So, I mean, because there's a lot to discuss in the test. So 1 to 2 pages will actually be pretty easy to write. So just keep that in mind. But that should be your litmus test is it summarizing everything that you've done? Okay, I do want a section on the use of generative AI. As I said, I actually don't have a problem if you use AI for the creation of your lab report, but I do have 3 requirements. Okay, the first requirement is I don't want you to use it to manipulate data or do any computations. But again, the data computations in this lab report are really, really easy. So I'm sort of thinking it would be overkill to use ChatGPT or something like that for that anyways. Second thing is I do want you to tell me how you used it. So there are a number of ways that you could do that. It could help you in proofreading. It could help you with brainstorming some things, your notes and some conclusions and whatnot. That's fine. But I just want you to tell me how you use it. Third, and probably most importantly, is what is in your lab report is what you are going to be responsible for. And the big example that I like to use in situations like this. So, for example, if you go to ChatGPT and you ask it, what are some sources of error? It's going to give you really, really great answers that might have absolutely nothing to do with what your group experienced as a source of error, or there might be deviations between what it's stating and what actually happened. Like for example, I know that there was at least one group in the class that had an issue with their air content reading, and it was just the pressure vessel was having trouble achieving a vacuum. And it's okay, stuff happens, but it's really easy to just have ChatGPT say, give me some sources of error with an air content, and you just put that in your report, and it doesn't make any sense because that group wasn't even able to do the air content reading. And so it's going to be pretty easy to determine if AI just spat out a bunch of really good answers that don't apply to what you did in the lab. But again, to be crystal clear, that's not me saying don't use it. I mean, if you want to use it, that's fine. Just tell me what you used it for and be responsible for what you submit at the end. I actually think it would be really good for proofreading. I've got some suggestions in the lab report guidelines on ways to word things and ways to phrase things. I think would probably be pretty good to go through your lab report and, is your report written in a scientifically proper fashion? It actually would probably be pretty good at that. So that's fine. Just make sure that you're honest about how you use it. The bulk of the grade is going to come from these four sections. So the test procedures, I want you to describe in your own group's words how you did what you did. I believe that probably one of the best sources for your test procedures section are the notes that you took during the demo, because you watched Patrick and I go through and do the lab, the fresh casting lab with you, and then you went and did it yourself. And I noticed during that day that a lot of you were referring to those notes, and so you took notes, you did the exercise. So how did you what were the notes correct? Were they not? That's probably going to be the best source of knowledge in your head for the purposes of writing that test procedure section. Graphs, obviously graphs, reducing the data, all your computations, that's going to be very important. I'll talk briefly in the guidelines section about some formatting on that. Again, sources of error, I want your descriptions. And one thing I'll say is I do want to make sure that the sources of error are like adequately described. So I put here an example in the bullet. Let's say for the sake of discussion that your mixed design, you think your group's mixed design was off because the absorption value was inaccurate. Okay, that's fine. But if you just say what's the source of error, you say absorption. Well, what do you mean? How is the absorption error an error? So give me some description so that I understand what you're saying and why you're saying it. Just listing a word is not enough. You've got multiple students in your group. You've got plenty of time to write that out. Your conclusions. Again, with a lot of these sections, I don't care if the procedures, the conclusions, all this are in bulleted, numbered lists. That's fine. But make sure that the discussion is clear. If you want to write it out in paragraphs, that's fine. If you want to write it out in bulleted lists and sentences, that's fine too. Just make sure that it's not just, data was good, data was high, data was low, or whatever. Like put some effort into the description as to like why things are the way they are. For the appendices, just attach your group's data to the back of the report. Okay. All right. This is the grading sheet that I'm going to use. And so you can see the cover page, the introduction, test procedures, all that have various different weights and whatnot. Now, I'll say this. If you add up all the sections of the report don't add up to 100, because I do have a section here at the end where I'm just going to read your report high level and try and ascertain, did you fully understand the details, purpose of the lab, or based on your writing, did it feel like you didn't understand what was going on? So I am going to assign grades based on that. I have in each of the sections what I'm looking for, what I'm after. So you should review this rubric in detail. I'm not going to sit here in this recording and read every single bullet here, but as you're writing a given section, so for example, here's a simple one. Let's take the cover page. Does the cover page have all the necessary required information? Are there any spelling errors? Is it professionally presented? If all those boxes are checked, you're going to get full credit for it. But if you're missing something, there's going to be a doc for it. So just make sure that you're aware of that. And then the this guide here can, like, for example, if we're talking about the cover page, this is what all should be on the cover page. So you've got a guide to go off of. So yes, go through this, review it with your group as you're writing section to section. I think that you should sort of be going back to this to make sure that it's being followed. I think it's probably a good idea, given the fact that you have multiple people in your group. It's not a bad idea to split up the writing effort. Maybe have one person write the test procedures, have one person write the graphs and data reduction, have one person write the sources of error, and then pass them around and have another person review it so that there's always two sets of eyes on every section. I think that's a really good way of doing it. And these days, you can set up the file in a file sharing fashion, and it will make your life a lot easier in that regard. So you can all set up like a um, either Google Doc or a Microsoft Word, shared document, and you all can edit it on your own in the fly. I sort of prefer Word in that regard because it ties well to our Marshall OneDrives and whatnot. But you do you. Okay. Final document is the report template. And so most of this is just, how to format your sections, how to format, the graphs and data reduction and whatnot. But I'll highlight two things that I think are noteworthy in this. So the first thing I'll identify is this list of 23 items and whatnot. This is sort of guidance for you in terms of how to word things, how to state things in your report. I think in class, when it's my job as the professor to teach you these, materials related concepts, I'm will be the first person to admit I probably use some more simple terminology or more basic terminology than I should. For example, today in lab, we're going to break some cylinders. Okay. And I'm sure I've probably said that in class, but I wouldn't write that in a homework assignment and I wouldn't write that in a lab report. I would write, what is the compressive strength of this cylinder? What is the flexural strength of this beam that was loaded to rupture and whatnot? And so I'm using specific terminology in the report as I'm writing it. And the reason that I'm insisting on that is I want to make sure that if I take this report and give it to some arbitrary engineer working on a different product or project, that they can read my report and totally understand it. And the way that we can ensure that is we use a consistent technical version of our terminology and whatnot. So I'm going to make sure that your report is written in a technical fashion. Okay, I think there's a big difference between just communicating, in a verbal fashion from engineer to engineer. If you're on let's say a project Zoom call, you can mention cylinder breaks. I think it's okay. But if you're conveying that in an official fashion from one engineering firm to another, you need to use a proper terminology. And so I'm going to insist on that for the writing and the format of the report. Okay. This is the cover page. I've got the cover page here. I've got the format for the table of contents. I've got the format for all of the different sections in the lab report. In each section, I'm going through and generally saying like what you should do. So for example, in the introduction section, this is what I'm after. So this should be, so between what I'm asking for in the section and how I'm going to grade it, those should be your respective North Stars for the purposes of grading the or for generating the assignment for you, because they're going to be my North Stars for grading the work. The only other thing I wanted to mention on the lab report template, and we'll discuss this probably next week when you all are really in the thick of getting your report together, is when we look at this section here, for example, on the graphs, data reduction, and calculation section, I put in here some sample tables. I've got here some sample figures, but I want to be clear, this is not an exhaustive list of tables and figures. And honestly, based on how your group decides to present the data, it may not even be a correct set of tables and figures. Your group might look at how I'm presenting data and you might think there's probably better ways of doing it for what we're trying to say. And that's fine. The purpose of this chart and the purpose of, let's say, this chart is I wanted to make sure that the format was clearly defined. The idea that the x-axis and the y-axis are clearly labeled. I know that the y-axis is representing compressive strength. The units are in PSI. This is the specimen age. The units are in days. I have a clearly defined legend indicating group to group, and so on and so forth. But in terms of how many plots there are, I'm using X and Y scatter plots here. Down here, I'm using bar charts. How you choose to present that is on you, and I'm not going to micromanage you in that regard. The only thing that I want is I want your discussion to be clear. I want it to be comprehensive, and I want it to be complete. And so I am being a little open-ended on that because I kind of want your group to get together and look at this data and go, okay, what are the conclusions? What can we conclude about our group's test data versus everybody else's test data? How are we going to do that? That's the purpose of this. I want you to investigate this data and come to your own conclusions. So all I'm giving you in this report is just an example of the graphs that if you include them, this is kind of how they should look. Beyond that, That's up to you on how you do that. Okay. And that's all I have for this lab report guideline discussion. Again, we're going to discuss this together in class next week. So next week, we're going to have a lab report Q&A, and you all are going to have oodles of time to work on this on your own. But with that, that's all I've got in this recording, and I'll see you in class here in a little bit.